all happy. Hi Lopa. Hi Dhwani. Hey Lopa, what are you taking next year, ma'am?
Oh, next year I'm taking IB math.
IB math. Oh, okay. It's not It's not related to any AP standards, is it?
Yeah, I think it's weighted the same as the AP class, but it's just called something different and like, yeah. But I'm just planning to take the standard level because it's just a lot simpler, but it's still weighted the same as higher level. So,
Oh, so is it calculus?
I'm actually not too sure. I think the syllabus is calculus, but it's just simpler because the teacher, they grade easier and like the work is simpler.
Oh, so more of AB calculus, huh?
Yeah, probably. I'm not too sure because it's my first year taking it. Like next year's gonna be my
Yeah,
first year.
yeah, yeah. I hear you. Okay. Okay. So, Parvini, you have the test upcoming or is it done?
We had the test today, but I wasn't feeling well, so I didn't go.
Oh, you weren't feeling well. Okay, okay. So we can go ahead and work on the polar graphs, right?
hmm
How are you feeling with polar graphs? Is it easy?
Um, we had a small gap in spring break, so like I need to
I know, I
go
know.
over it.
Hi, Manav. What are they teaching in school, Manav?
Uh, trig equation, sum and difference, double angle, and inverse trig.
Oh, wow. Okay. So they have not
We
come
have
into
I have a test on that tomorrow.
trig equations. Okay, but I really want to get going with polar graphs. There's a lot to learn, and then vectors is there. Shall I go ahead with the polar ones? You'll find it
Yeah,
so good if you know it before.
yeah.
Dhwani, how about you? Dhwani and Krish, how about you?
We started this week on polar graphs
Oh, nice.
and
Okay,
complex numbers. Use like writing the polar coordinates
that's
in like
nice.
complex
Oh,
using complex.
that is so nice. I want to go over that for sure. Can we get started? Okay, we did discuss only the formulas, right? Rectangular to polar, polar to rectangular. We did discuss the formulas, but we didn't go through it fully. Let's go through it fully. Okay, and then I'll move on to the graphing piece as well. Okay. First, I want to do polar to rectangular. Okay, polar to rectangular. Okay, suppose if I give you r comma pi 6 comma pi by 3. See, polar is given as r comma theta, right? So that you'll convert it to rectangular coordinates. Okay, so that will be x comma y, right? So if you're given this, right, in a polar graph, how do you convert it to rectangular coordinates? When you think about it, right, here, remember, so let's say this is theta, uh, this is theta, this is the angle, right? So this piece is y, this piece is x, this piece is r basically. Suppose if this is the point 6 comma pi by 3, let's say. So now this is r. So naturally, if you write trig for this triangle, right? So you go ahead and say uh, cos theta equal to x by r, sin theta equal to y by r, x equal to r cos theta, y equal to r sin theta. So this is basically the formula for converting polar to rectangular. So in rectangular you have x equal to r cos theta, y equal to r sin theta. So this is the way you convert from polar to rectangular coordinates. Can I move on? Can I move on? Now, would you be able to convert 6 comma pi by 3 and tell me the answers quickly? Use 6 comma pi by 3. Tell me the answers as x comma y. That's all. We'll move on from there. Guys, you can be fast. I really want to cover today a lot of graphing. I'll try to cover all of it. Let's see. It would be nice if we can cover all of it and have vectors next week, but that's not going to happen as well, I feel. Let's see. Parvini, I wanted to tell you something. The vectors that's going to come up for you, right? That's not a part of AP Pre-Calc. That's not a part of the AP Pre-Calc exam. You know that, right?
Yeah.
Okay. They are just teaching you and having a test at school, that's all. But it's good to know vectors, bearings and stuff. Shragvi, what are you doing in school? See guys, I was asking you to convert 6 comma pi by 3, a polar coordinate to rectangular coordinates. That was the question. Can you guys do that? Advik, what are you doing in school?
We just learned the pie chart yesterday.
Okay.
WhatsApp on.
Go ahead, guys. Can you just message me? Send the answers, guys. Quick. If we can do it quickly, I can move on. Dhwani, good job, ma. Okay. Guys, I hope you got it. So it is just plugging in, right? So this is 6 cos pi by 3, 6 sin pi by 3. That's all, guys. Okay. So let me move on. Now I really want you to convert, we did polar to rectangular, right? Next thing I might want you to do is rectangular to polar. So how do you do rectangular to polar? Okay. Let's see this again. We will do rectangular to polar now. So we are going to convert from xy form to r comma theta form. So basically, when you think about it, again, this is x, this is y, this is r, right? So x square plus y square equal to r square by Pythagorean theorem. So r will be equal to square root of x square plus y square. Similarly, for the theta, we can say tan theta equal to y by x, right? Here, so theta will be equal to tan inverse of y by x. Any questions here? So this is the formula for converting to rectangular to polar. As a sample, let's go ahead and try this one. See, this is a little tricky. I really want you to try this one. Minus 3 comma 5. Minus 3 comma 5. This is a little tricky. So I would really want to intervene and do this, but I want you to try. Minus 3 comma 5. See guys, when they have given you the rectangular coordinate, first determine your quadrant. Which is your quadrant? Minus 3 comma 5 falls in this quadrant. Right? Now go ahead and try to find out r comma theta values. It's interesting. Please put it in radians. Put your calculator in radians. Try to plug in, find out the values of r comma theta. This is definitely tricky, meaning, let's see.
Should we simplify the square roots?
Yeah, ma, put it in decimals, guys. One more thing, I really want you to find out theta between 0 to 2 pi. 0 meaning theta value will range from 0 to 2 pi. Please, in this interval, you are going to convert this rectangular coordinate to a polar coordinate. It's teeny tiny bit tricky, guys. So why don't we try? I'll give you 2 problems in this. We will revisit the same topics, but at the same time, we will have a fundamental understanding of each topic whenever we discuss the first time. Advik, are you able to do Advik?
Yeah.
We'll once more revise the polar coordinate, the 4 ways of putting the polar coordinate as well. One more time after this. Guys, are you waiting for me? Do you want me to solve? You have to let me know, please. Shri, I want you to be on the video, Shri. We are working on polar to rectangular and rectangular to polar coordinates. Dhwani, did you get it?
I figured out like the radius, and I know how
Okay,
to like
once.
do it, like the tangent part of it, but I can't figure out like the exact number for this one.
No problem. So this is r square, x square plus 9 plus 25, right? Did you get this, ma?
It shouldn't be root 34.
Oh, I made a miss. Okay, root 34. What is the value, ma?
It's like 5.83.
5.83. Let me quickly check the answer. Okay. Can I say it? One second. Yeah. Okay, root 34. Let me have it as root 34. Okay. So root 34 and then what? 5.83. Yeah. Okay, that's fine. And then theta. Theta is what makes it hard. What is theta's value? Theta is tan inverse of 5 by minus 3. What is the answer, ma?
Oh, so I can just calculate it like that. I don't need to like get an actual pi next to it.
I will tell you. I'll tell you. Tan inverse of 5 by 3. 5 by minus 3 means where does it land? What is the answer for that? Tan inverse of minus something. What is the answer? Theta will be equal to, is it minus 1.030? Guys, you have to tell me, guys. Manav, did you get it? Krish, are you getting it?
Yeah, I think so.
Minus 1.030. The problem is minus 1.030 means what? This is 0. This is pi by 2. Pi by 2 means what? 3.14 divided by 2, 1.57 radians. This is minus 1.57 radians. This is 3 pi radians, right? Which is 3.14 radians, right? Otherwise, what you can say, this is 3 pi by 2, 1.5 pi, right? So it is basically 7, 8, 9, 10, 11, 6. This will be 4.61 radians or minus 1.57 radians, right? So when you get minus 1.030, if you think about it, automatically it is pointing to an angle here. Is this right? But basically this rectangular coordinate is a part in the second quadrant. So what should you do to adjust this? What should you do to adjust this? So you will go ahead and add pi to this. making your angle come in the second quadrant. So if you add pi, that is 3.14, right? What happens now? Add pi and your answer matches 3.14 minus 1.030. So 0, 1, 1. So basically it is 2.11. So basically r comma theta is 5.83. So the answer I'll write it here, guys. So the answer is 5.83 comma 2.11 radians. Make sense, guys? So see, when you convert rectangular to polar coordinates, the main thing you need to be careful is, oh, this one is in your second quadrant. Okay, you are getting the angle in fourth quadrant. So you'll have to push it, because see, tan inverse, right? Tan has a period of pi. So basically to push it there, right? To push it to your second quadrant, you'll go ahead and add pi to it and then tell the angle, because this is minus 1.0 something is this angle, but you need to push it 180 degrees. So that will come to your second quadrant. Make sense? So let's try one more. Let's see. How about 2 comma minus 6? 2 comma minus 6. 2 comma minus 6. Shri, are you listening?
Yeah, I'm here.
So convert from rectangular to polar. Okay. R comma theta within 0 less than or equal to theta is less than or equal to 2 pi. Can we convert and quickly say the answer, please? So basically, please find the quadrant first. 2 comma minus 6 is 2 comma minus 6 is in here. 2 comma minus 6 is in here. Remember where you are, in which quadrant, and after that do all this, x square plus y square. So r will be equal to, theta will be equal to tan inverse of minus 6 by 2, which is tan inverse of minus 3. I'm going to wait for your answers, guys. Yeah, ma'am. Did you get it? Guys, I really want you to try this one out. I'm not going to do it on the board. Shagvi, are you getting the answers?
Yeah, I'm doing it.
Mm-hmm. Parvini, how about you, ma?
I'm doing it.
Advik, is that the answer for this one? Oh, wow.
Yeah.
Very nice. Did you adjust? Did you adjust the angles?
Yeah, so that it's in the fourth quadrant?
Yes, nice.
Yeah.
So you were getting it in the second quadrant, correct?
Yeah.
Nice. Manav, are you able to do Manav?
Miss Priya,
Yeah.
when we like originally do it, like we did the tan inverse thing and we get like a negative number,
Yeah.
would
I'll
that
tell you.
technically be in like the fourth quadrant? Because like you can do negative pi over 3, pi over negative pi over 6. Would that still technically that negative count as in the fourth quadrant?
Correct, Ma. So what is the answer for this one? Let's do it together. Tan inverse of minus 3 is what?
Oh, it's like negative 1.249.
Negative 1.249. Yes, it is in this quadrant, but when you think about it, let's wait and let's see, wait. 2 comma minus 6, so it's technically in the fourth quadrant. But yes, it's technically quadrant is good for this one. Okay, it's technically in the fourth quadrant, but the problem is you have to find out angles within 0 to 2 pi.
Okay, never mind. It can't be negative, so I'll have to keep adding pi. Okay, I see.
You have to keep you have to keep adding 2 pi in such a way that it comes to the fourth quadrant. So you will end up adding 2 pi.
Yeah.
Makes sense? Yeah.
I got something around like 6.32.
6.32. Correct. 6.32 is the R value. That is correct.
Oh, okay.
R value is 6.32. I'm asking for the theta value. Theta value is tan inverse of 3, but tan inverse of minus 3. However, that gets you to minus 1.243, which is in the fourth quadrant. However, you're asked to have the angles between 0 and 2 pi, but it is this angle is less than 0. It falls here. It doesn't fall in this interval, right? So you will have to adjust it by adding 2 pi because why do you add 2 pi? You don't want to go to the second quadrant. You want to bring it to the fourth quadrant.
Yes, you add the period. Yeah.
Yep. So you add 2 pi. Can I move on?
Yeah, that's fine.
Yeah. So that is on conversion from polar to rectangular and rectangular to polar is done. Lopa, did you get it, ma? Shragvi, I didn't get your answers.
Miss Priya.
Yeah, I
ma?
understand.
If you keep adding 2 pi, won't it be positive and not be in the fourth quadrant?
What do you mean by that? Hold on. What is your question?
If you keep adding 2 pi to negative 1.24, wouldn't it not be in that quadrant then?
See, ma? 0, pi by 2, pi, 3 pi by 2. Okay, and then pi, this, when it comes again, it's 2 pi. Again, when you make another round, it's 4 pi. Again, when you make another round, it's, you see what I mean? 6 pi. So, this, basically, this was minus 0.1243 radians, right? But this does not fall within 0 to 2 pi. The answer should be a positive number and has to be between 0 to 2 pi. This minus 1 pi, this falls here, right? So you add pi to it. If you add 3.14, it falls within this. But the problem is it goes to the second quadrant. If you add pi, it goes to the second quadrant, right? So you will have to add 2 pi to bring it back to the fourth quadrant. Does it make sense?
Yeah.
Pi is the period for tan, ma. So you can add pi, that's fine. But then if you add pi, yes, it falls within this range, even if you add 1 pi. But the problem is when you add 1 pi, the angle goes to the second quadrant, right? You have to bring back the angle to the fourth quadrant. So you add 2 pi, that way it remains within this range and it is in the fourth quadrant.
But I got 5.03.
Correct, that is correct. 5.03 is correct. 034. Can I move on?
Yeah.
Okay. Now, okay. If suppose in imaginary numbers, how do you plot this? Krish, are you doing? I'm not sure whether you're doing. When it comes to imaginary numbers, right? Manav, are you doing? Imaginary number. See, here, this is called the imaginary axis. Okay, like in a see, for a real number we had x and y axis, right? Like that we have the real axis, the imaginary axis. Okay, So if you have 3 plus 4i, how do you plot it here? 3 on the real axis, 4 on the imaginary axis. This point is 3 plus 4i. Make sense? Suppose this point is 2 minus 2i. Make sense, guys? This is how you plot on the real versus imaginary axis. All the while we were plotting on x and y axis in coordinate plane, right? Now, how do you find see, these are called complex numbers. Complex numbers are of the format a plus bi that we learnt in algebra 1. Now, the magnitude, or I don't want to include magnitude now, okay? Absolute value of a complex number. We are talking about complex numbers now. Absolute value of a complex number. How do you write it? Square root of a square plus b square. Here you write it out as square root of a square plus b square is the absolute value of a complex number. Can I move on? Okay. Now, in an imaginary, let's say this is an imaginary axis. This is an imaginary plane. Okay. So you're going to tell me what this point represents. What does this point represent? Anybody, guys? The dot point here. What does this dot point represent? Guys, anybody who you can volunteer and say, yeah?
The polar coordinate.
No, I just need the see, this is real axis, imaginary axis, ma.
Okay.
So it will be a real number. See, it will be of the format a plus bi. So what does this point indicate?
Negative 4 minus 3i.
Negative 4 minus 3i. Because on the real axis I have negative 4. And then on the imaginary axis I have negative 3i. Make sense? Shragvi, are you following, ma?
Yeah.
Okay. So, what else? You know how to convert rectangular complex numbers, oh my gosh, to polar form. Yeah. Yeah. Suppose if I give you, okay, you should be able to convert rectangular complex numbers to polar form. Let's see, we were just converting rectangular numbers to polar form. Now we will convert rectangular complex numbers to polar form. Let's do one at least so you get to know what it is. Okay, first what we did was, let me go ahead and write down what we did. We'll really understand. We did rectangular to polar coordinates, right? And then we did polar to rectangular coordinates. Right, here we did x, y will be equal to r cos theta, r sin theta. What did we do here? Rectangular to polar coordinates, r and theta, right? So we did square root of x square plus y square, theta will be equal to tan inverse of y by x, and we adjusted the quadrant and the theta values to be between the intervals given. So this is what we did. But now we can be given, this was all real. Real means we only considered x and y axis. Now we are going to convert rectangular complex number to a polar coordinate. Can we try that? So what is that rectangular complex number? This one is like 3, 4. This rectangular number you are converting to r, theta, or r, theta was given, you wrote it out as x, y. Now I am going to give you a plus bi number. You are going to calculate the polar coordinate. For this, the same thing holds good. There is no big change at all. Meaning 3, 4, right? To convert it to a polar coordinate, the same thing you will use, but you will be using a square plus b square here. Similarly, tan inverse of b by a. Okay, so let's see. But let me show you. But there's one variation in that at the end. So I'll show you. Okay. So minus 3 plus I root 7. I would really like you to do minus 3 plus I root 7. If I give this rectangular complex number, would you be able to change it to polar coordinates? Minus 3 plus I root 7. I really want you to be able to do this. I want you to convert to polar coordinates. So for that, to convert into polar coordinates, you need r comma theta. R is given by square root of a square plus b square. Theta is given as tan inverse of b by a. But you need to adjust the coordinates and stuff. Can you do that for me? Slightly tricky, guys, though. R and theta will get it, but finally to express it, we'll express it in a different format too. Go ahead and try. I'll do the last part. You just need to know what is this polar complex number. See, the way we write out rectangular complex numbers is a plus bi. The way we write out complex number in polar form is a little different. Why? Because this is r. Let's say there is a complex number z. The complex number z is a plus bi in rectangular form. Okay, we want to write the same complex number in polar form. It's slightly a little bit different here. Here, this is x, this is y, you know. So basically, when I write a complex number in polar form, I would want to write it out as r cos theta, comma, I sin r sin theta. This is how I would want to write down. So this is a teeny tiny bit tricky. Here, let's go ahead and write out, this is my rectangular complex number which I gave you, minus 3 plus I root 7. From here, you need to find out r and theta, but that's not enough. R comma theta is not how we represent a complex number. So we will go ahead and find out r cos theta plus I r sin theta. This is how we are going to represent a polar complex number. So when I write the z in polar form, I'll write it out as r cos theta plus I r sin theta. So let's go ahead and find out r and theta here. It is very similar to converting rectangular to polar. However, it does not stop there. The way we represent a complex number in rectangular form is a plus bi. Similarly, the way we represent a complex number in polar form is slightly different, and it is represented like this. So after finding r and theta, you'll have to substitute into this and write down your polar form. Can we try, guys? I can as well try. So what is r value for this one? What is r value for minus 3 plus I root 7?
We have to make it back into rectangular.
No, this is not, see, that's why, Mano, this is not rectangular. You see, this is not rectangular. This is the polar form of a complex number.
Oh.
Does that make sense? This is the polar form of a complex number. Am I making sense?
Yeah.
Okay, let's see this one. See, x comma y coordinate is the rectangular coordinate. Now you're going to convert it to r comma theta. This is the polar form. Okay, all these are with real numbers. Okay, we entered the realm of complex numbers. It's a little tricky. Okay, complex numbers you generally write it down as a plus bi. Okay, even the rectangular form is written in the format rectangular form is a plus bi, right? Now the polar form is not just r comma theta. Instead, it's written as r cos theta plus I r sin theta. So from here you find the r comma theta, then you have to write it in this format. Okay, the short form of this is r sin theta. Let's not use this, okay, because in AP Pre-Calc nobody is using this, but when we were studying honors Pre-Calc we did use this a lot many times, okay, but I am not going to use this at all. Okay, so this is going to be r cos theta plus I r sin theta. That is the polar form of a complex number. So what I asked you was, can you please convert minus 3 plus I root 7? So the task given was minus 3 plus I root 7. This is a rectangular complex number. I wanted you to change it to polar complex number. Polar complex number is written in the format r cos theta plus r I sin theta, right? So I really want you to be able to write it in this format. Can we try? Can I help guys, or you want to try?
Wait.
So what is the r value, guys? Okay, I have some answers.
4.
Yeah, ma, 4. Yes, you adjusted the theta value as well very nicely.
No, I'm not gonna use
Manu, the theta value is correct, Manu.
Just set it up in the
Oh.
Because this,
Wait, should you add pi or 2 pi?
you tell me. See, this coordinate, the given rectangular complex number is in which quadrant? It is in the second quadrant, right? But
Yeah.
if you get a minor, yeah, so let's see this. Let's see this.
Oh,
So
it can only
here,
be in the fourth or first quadrant.
this one, see, minus 3 comma root 7i is a positive number. So somewhere here, right? This is the coordinate, right? But when you find the r value, right? R value was 4. So basically that is 3 square plus root 7 square, correct? So that
Yeah.
will be 9 plus 7, 16, right? That is equal to 4. Theta value will be equal to tan inverse of root 7 by minus 3, right? What is that?
Like negative
Minus, I'm getting
0.722.
0.722. Huh?
I think I got
Minus
0.722.
0.722 is somewhere here, right? Because
Yeah.
this is 0, this is minus 1.51 radians, right? So
Yeah.
this is minus 0.722 is here, minus 0.722, almost half. However, this is minus radian. However, we wanted the coordinate to be in your second quadrant, right? So you add the pi value to this. So what happens? 3.14 minus 0.722
Oh,
becomes,
I added 2 pi.
then it will come to the fourth quadrant, right?
Yeah.
Yeah, so 2.418 I'm getting. So 2 comma 2.418 I'm getting for theta. Now how do you write it? Writing it is a separate skill again, because we need to convert it to polar complex number, where it is written as r cos theta plus I r sin theta. That format you need to write down. So you'll write it down as 4 cos 2.418 plus I times 4 sin 2.418. But we won't end up like this. Take out the 4 as common, then you write it out as cos 2.418 plus I sin 2.418. This is how you write it. Makes sense? This is the number finally. Akash, are you getting it, Akash?
Yeah.
Okay, can I move on? Advik, did you get it? Lopa, did you get it? And Shragvi, I'm not getting positive response
Yeah,
from you.
I sent you my answer.
Oh, I didn't see ma. Two people I didn't see. Shragvi, yes. Yes, nice. Okay, so let's move on from here. Okay, now rectangular complex numbers to, okay. How about this? How about this? I wanted to convert polar complex number to rectangular form. Polar complex number to rectangular form. Let's see. Polar complex number to rectangular form, that will be the last one. Polar complex number to a rectangular form. So we'll see polar complex number to rectangular complex number. Let's try this one. This one is pretty easy, just the reverse, right? So let's see this one, 4 cos 3 pi by 2. Let's have one example. 4 cos 3 pi by 2 plus 4 sin, or let me write it in the standard format. Sine 3 pi by 2. I'm giving you this number. You're going to convert it to the rectangular complex numbers. That means I want you to write it in the format a plus bi. Can you try this one, please, guys?
Where's the I?
Huh?
Wait, where's the I?
Sorry, Mana.
It's fine.
So it's pretty easy to do this. That's why I did not give you a sample, because theta is directly given, r is directly given. So what are you going to do? A is basically A is basically 4 cos theta, B is basically 4 sin theta. So not a tough one. Advik, can you calculate that and see? It's not this complex. It's a very easy number.
That was for the last one.
Oh, sorry. Yeah. But was it 1.977? I didn't get that, right? It was 2.418, right? Advik.
Oh yeah, I think I messed up somewhere.
But did you understand why and where?
Yeah.
Okay. Did you get it, guys? Shagvi, did you get ma? Dhwani, that is correct ma, but you don't write it like this, right ma? Complex number, right?
Sorry. I
No,
was
no,
trying
no. See, as long as you understand, I'm fine, ma. Parvini, you don't write it like this, right?
I didn't send my answer yet.
Okay, but the previous one was not this answer, right?
That was for the first question we did.
Okay. Yes, ma. Dhwani, you got it. One of you made some mistake. Dhwani, is it positive or negative?
Oh, it's positive, right? Oh, it's 3 pi over 2 minus negative.
Yeah, Akash. I think you as well got it. So, yeah, at least, meaning, see, fundamentals, if you understand it here, when school teaches you, it's going to be very easy. If school has already taught you, anyway, you're going to have your exam, AP Pre-Calc exam. So, patch all the gaps you have is my honest thought about this. So, this is yes, minus 4i is the answer. This is x will, you need to find out a and b, right? So this would be minus 4i would be your answer. So basically this is x equal to x cos theta y sin theta, right? X cos 3 pi by 2 r, I mean this one. Again this is 4 sin 3 pi by 2. So basically this will be 0, this will be minus 4. So that tends to be minus 4i. 0 is the real part. Now I'll move on, guys. So we covered all the conversions nicely. Now suppose if I say suppose if I say theta will be equal to pi by 3. What sort of a graph will it be in a polar coordinate? What sort of a graph will it be when I say theta will be equal to pi by 3? What sort of a graph will it be if I say theta equal to pi by 3? Guys, in rectangular coordinates, when I said x will be equal to 3, what we did, this was our line. When I said y will be equal to 4, if I said that, the answer would have been this, right? Similarly, when I say theta equal to pi by 3, what sort of a graph will it be? Any thoughts? Theta will be equal to pi by 3. How will the graph be? Guys, you're going to guess. What sort of a graph is it going to be? Irrespective of r value, your theta is always going to be pi by 3. So what is that graph? It's going to be a line graph. Suppose, okay, next I want to know how is my graph for r equal to 5. What sort of a graph is that going to be? Let me put it out as r equal to 2. What sort of a graph is that going to be? Guys, you can rise up, say something wrong.
Wait, Miss Priya,
Yes, ma.
r equal to 2 considering the pi value? Sorry, the
No,
critical
r
value.
equal to 2 is my, see, I was only asking for y equal to 4, x equal to 3. Like that, there are only r comma theta, right? My equation is r equal to 2 or theta equal to pi by 3. Theta equal to pi by 3 really maps to a line, right? This is the line graph. This is the graph for r equal to pi by 3. But r equal to 2, what happens?
That would be a circle.
Yes, r equal to 2 is going to be a circle. Irrespective of theta values, r is always going to be 2. So the graph is going to be a circle. Make sense? Okay. Can I move on? So you need to know that. Okay. R equal to 0 is going to be a circle graph. Theta is equal to any value is going to be a line graph. Okay. Now let's move on. Remember guys, see again, to reiterate, this is called the polar axis. In a polar coordinate, that's called the polar axis, right? In a rectangular coordinate, this is going to be the x-axis, this is going to be the y-axis. Okay, now let's go ahead. Okay, now I'm going to bring up a polar graph and I'm going to plot r equal to 4 cos theta. Guys, we are going to enter into polar graphs. Okay, I really want you to remember, observe, okay, and just grab the basics here. Okay, let's see. Let's see. Polar graph. I really want a polar graph image. Let's see. Can I get a polar graph completely? 1 second, guys. Yeah, I can go to GeoGebra directly. Let's see. One second, guys. GeoGebra is a very good site for polar graphing. Please note down GeoGebra. It's very nice to work on polar graphs in GeoGebra. But I don't. Oh my god. I don't know which site is good to draw to show you graphs. Let's see. Yeah, this is okay. So. But this is not what I want. Let me bring up an image, guys. Hold on. I just need one image of a blank polar graph. 1 second. I'm going to do it on the board itself, okay? Okay, do I have radiance? Yes, I think this is good. Okay, let's do this one. Oh my god, it went off. Hold on. I just need radiance and then, yeah, this is a good one. Okay, let me use this. Okay guys, I'll use this picture. This picture is good. So here I'm going to do the graph for r cos theta. R cos theta. So I'm going to draw the graph for r cos theta. So I would go ahead and start from 0, pi by 6, pi by 4, pi by 3. I'm going to do pi by 2 and then 2 pi by 3. Then I'm going to move on to 3 pi by 4, 5 pi by 6 and then a pi. Okay, so this is my theta value, that's my x value. The y value is going to be r cos theta. So here this is going to be theta, this is going to be the y value equal to r cos theta. So I'm going to graph this, okay. So for 0, so let's start computing this. let's say I want to do 4 cos theta. What will be the value here? You are going to help me, guys, with each value. What will be the value there? 4. You can, I'll do it as a decimal, guys. 4, then 4 cos. I'm going to plug in the theta values there. Okay, I'm going to plug in the theta values there. Just going to write the values: 3.464, 2.828, 3.464, 2.828, 3.464, 2.828, and then I calculated for pi by 4, correct. And then the next one I have 2 and then a 0. 2 pi by 3, what I'm getting? Minus 2 minus 4. So I'm getting a minus 2, then this is a minus 4, then this one is a minus 2.828, and then this one is a minus 3.464. Any questions? I'm just plugging in values. Now I'm going to plot this into the graph. 0, 4 goes here. 1, 2, 3, 4. Okay. Now the next one would be pi by 6. Pi by 6 is 3.464. 3.464 will be somewhere here. Then pi by 4 is 2.828. So that would be 2.828. Then the next one is 2 for pi by 3. And then the next one is pi by 2 is a 0. And then 2 pi by 3 is a minus 2. 2 pi by 3. Minus 2 means this side of the graph. And then 3 pi by 4. For 3 pi by 4, when you think about it, it's minus 2.828. Minus 2.828 means minus 2.828, somewhere here. And then minus 3.464 for 5 pi by 6. 5 pi by 6 minus 3.464. Guys, that should be a little before. Does that make sense, guys? So we started from here and went here and then went here, went here, went here. Am I making sense? Guys, did you see how 4 cos theta graph looks like? Do you see how 4 cos theta graph looks like? Any questions here? Okay. Suppose if this is going to be minus 4 cos theta, how will the graph change? If it is going to be minus 4...
Reflected?
Yes, it's reflected on the... Here. It's going to be like this.
Y-axis, yeah.
Yep. This is going to be minus 4 cos theta. This is going to be plus 4 cos theta. Does it make sense? The graph?
Yeah.
The highest point would be minus 4 here. The highest point would be 4 here. Any questions? Now, same thing if I do for 4 sin theta. How the graph is going to be? So I'm going to do for pi by 6, pi by 4, pi by 3, pi by 2, 2 pi by 3, and then what? 3 pi by 4, 5 pi by 6, and then pi. So what is the cycle here? I'm doing only till pi. Do you see? Are you observing that I'm doing only till pi? So let's do 4. Let's do 2. 2 sin theta. How the graph is going to be? You want me to give you the values? I can give you the values as well. I'll do 4 sin theta. Okay, let's do 4 sin theta. We have the 4 radius itself. Okay, good. So let's do 4 sin theta. So 4 I'll start from 0, right? Sine 0 is a 0, so that is a 0. Then for pi by 6, what happens? Pi by 6, it's going to be 2. Then pi by 4, it's going to be 4, Emma. 1 by 2, right? And then pi by 4 is going to be 2. You would just plug into the calculator and write down the decimal values. And then this is going to be 3.464. Then this is going to be 4. This is going to be again 3.464. It's just a repeat. And then 2.828. Then 2 and a 0. So now I'm going to plot this. And I want to plot this into the graph. Let's see how 0, 0 is going to be a point. And then pi by 6 is a 2. And then pi by 4 is 2.828, and then 3.464 is pi by 3.464, and then you have the maximum 4 on pi by 2 because sine graph, so that's 4, right? Sine 90 is 1, so again 3.464 on 2 pi by 3, and then 2.828 on 3 pi by 4. And then you have pi, for pi you have a 0. So see the graph, guys. Any questions? So how will the graph for minus, we have represented 4 sine theta graph. How will the graph look like for minus 4 sine theta? It's going to be
reflected.
Yeah. Make sense, guys? This is the starting point for graphing of polar graphs. This is the fundamental thing that you need to know. One is 4, meaning a, let me put it in generic formats. A cos theta minus a cos theta, a sin theta minus a sin theta. So the format of graphs would be, see, at some point nobody is going to come with a table and show you. Okay, so you will have to know how that works. Minus a cos theta is this. Okay, this point would be a point. This point at pi would be the a point. Okay, now a cos theta, the positive would be this. Okay, this maximum point would be a. Okay, now similarly, a sin theta is going to be up. It's going to be here. This is a, right? And then the final one, minus a sin theta is going to be this. And then this is going to be the a point, the maximum point. Any question? Any question till here? You know how you drew the graph, right? X comma y. Usually you plot the table, right? Here what are you going to do? Theta comma a cos theta, whatever is given. So you are going to plug the theta values into this, find the corresponding values for pi by 6, pi by 4, pi by 3, pi by 2, 2 pi by 3, 3 pi by 4, 5 pi by 6. You know what? After pi, see what happens. After pi, if you go through all of this, right? When you look, meaning when we calculate for this, right? The thing is, I want to show you that as well. Let's do for 4 cos theta. So what did I see? What did we see? 0 to pi it went, and then I can go again from pi to 2 pi as well. I did not show you that, but then 0 to pi when it goes, right, for cos theta, what did we do? It gave you a graph like this, right? Now pi to 2 pi if you want to go, I want to show you that as well. Pi to 2 pi, from here you are going to go. I really want to show you in GeoGebra. This is important for you to understand. Let's see if I can show you in GeoGebra. GeoGebra is a wonderful site. I don't know whether you have discussed in school, but please make use of GeoGebra. GeoGebra is the website, okay, geogebra.org. Please make use of this and play with it, okay, you will have fun. Okay, now I'm not going to get you the rectangular form and all, okay, we are just going to do 4 cos theta. I just want to copy theta, guys, because it's very difficult. I'll just copy theta, and then I'm going to draw the graph for 4 cos theta. Okay, now I want to turn the animation on. See what happens. Do you see the graph? How, see, see the graph goes till, see the linear graph as well, see what happens. Yeah, I'll stop here. So when you think about it, see, it drew from 0 till pi. So basically it went till 0 to pi radians. See, pi radians 3.14, and then it started from 0. It started from 0 and then it went till pi radians. Did you see that? So what graph? We started with 0. 0 was a 4, the maximum. You see, 0 was a 4. In a linear graph, it will appear to be like this, right? And then when it came to pi by 2 is 1.57 radians, right? Then you completed this. It arrived at a 0. Then it at pi radians, see what happens again. Pi radians, it completed this and completed the cycle completely. Now what happens when it goes, literally we'll switch off the animation again, switch on the animation, see what happens. Pi to 2 pi, see again it goes through the same circle. See, by the time it completes 2 pi, it goes on another circle. See, that's the end of 2 pi. So what happens till pi, it draws out one circle. From here it starts and ends. This is pi. And then again it goes from pi to 2 pi like that. Are we clear, guys? Manav, are we clear?
Yeah.
Advik, how about you?
Yeah.
So one cycle gets completed within 0 to pi in this graph, right? So cos theta or sin theta graphs, the cycle is just 0 to pi, because from pi to 2 pi the same thing repeats. But in a linear graph it's a little different. From here it goes till pi here, and then pi to 2 pi is this graph. But then in a polar graph it just repeats. So here, that's what I wanted you to know in a polar graph for 4 cos theta, 4 sin theta. So a cos theta minus a cos theta, b sin theta minus b sin theta. You should know how to graph them. Okay. After that, let's see how about this. Okay. We want to go ahead further with graphing. Okay. I'm going to discuss. This is a nice thing to discuss, but I don't know. Let's see. I'm going to discuss 4 cos 3 theta and 4 cos 2 theta. These graphs are important, guys. I really want you to understand and do these graphs. Let's see. I want to come to the notes piece. It's here. Okay. So I'm going to do 4 cos, first let's do 4 cos 3 theta and 2 theta. I'm going to do 4 cos 3 theta and 4 cos 2 theta. Things are going to be different. Okay. We are going to have roses. This graph set is going to be a set of roses. Okay. Now we need to discuss on petals. How many petals, all that stuff. So now let's go ahead and do 4 cos 3 theta first. So if it is going to be 4 cos 3 theta, right? It's going to go like this, go like this, go like this, go like this, and go like. I really want to show you in GeoGebra again. Okay, 4 cos 3 theta will do. Yeah.
Really quick.
1 second, guys. Let me finish the class and come.
No, but Caltech.
One. Hi guys, so sorry. So let's see here. I am sharing the GeoGebra link with you guys. So we are going to do 4 cos 3 theta, 4 cos 2 theta. Are you all able to see my, this is better I think. 4 cos 2 theta, 4 cos 3, let's go ahead and do 4 cos 3 theta first. Okay, so I'm going to turn the animation on and we are going to check these graphs, okay. When you do 4 cos 3 theta, right, basically first let's understand the linear graph out of this, okay. 4 cos 3 theta, so basically the amplitude is 4, but the period was 2 pi, okay, the period was 2 pi for the parent graph, but this one the period would be 2 pi by 3. That means within 2 pi there will be 3 full cycles. We start here and go here, okay. Again within that 2 pi, this is your 2 pi, right? So within that 2 pi there will be 3 cycles. This is the second cycle, this is the third cycle. Any questions here? So 4 cos 3 theta is, 4 is your amplitude, and when it comes to your period calculation, the original parent graph, cos theta graphs have 2 pi as your period, but here 2 pi by b is your period, right? So 2 pi by 3. So it starts up and then goes to the same point within this. So this is 2 pi by 3 basically. Okay, another 2 pi by 3 goes here. Another 2 pi by 3 goes here. Makes sense? Now, when you think about this graph, right, in a polar form, right? I really want you to do it from the first. Okay, let's go here. So this is 0, right? So I'm going to push the graph from 0. Okay, where is this pi by 3? My pi by 3. See, here this is 1.57 is pi by 2, correct? So see the graph coming out. Then the graph goes to, this is your pi by 3. Do you see what happened? The graph is not yet complete. 4 cos 3 theta graph is not yet complete. So you want to keep going till the graph goes to the original position, right? See what happens. See, at pi, it goes to its original position. Any questions here? Any questions here? Any questions? So, when you have a cos b theta, right, b can be even or odd. So b is odd here. B can be even or odd. So a cos b theta, suppose b is even. Now what did we do? We just chose to do 4 cos 3 theta where b was odd. We will look at what happens when this is going to be even, that is 4 cos 2 theta, right? So we are going to try for both. Still the cycle I am seeing it as pi, 0 to pi, the graph completes, right? And again, if I continue till the 2 pi, what happens I am going to show you. If we continue till the 2 pi, from the pi, see again it draws out the same graph, you see, till I go to that 2 pi, see, it finishes the graph 2 times. So basically here as well the cycle is going to be 0, 0 comma pi. Any questions still here?
Priya, I have to go.
You can, Amma.
Alright, thank you. Have a good day.
Miss Priya, I have to go now.
Yeah, you can go.
Bye.
Bye. Let me finish this, guys. Now here it's going to be 4 cos 3 theta. It's going to be 3 petals. Okay, the number of petals is determined by this number in case of b being odd. Whereas, suppose if I draw it for 2 theta, right? See, 2 theta, what happens here? Let me bring it back. We'll start from 0. So, the graph When you look at it, I'm going to go till, see, the graph is not complete at pi. Do you see? The graph doesn't get completed at pi. So it goes through a whole lot of 2 pi fully to get it done. So 2 pi ends here. That is when the graph gets completed. So here the cycle is 0 to 2 pi. Okay. Then only the graph gets completed, and coming to the number of petals, right, it's going to be 2 times this value. 2n petals is going to be there. Makes sense? Or 2b petals, I would say here. So when you draw the graph for 4 cos, this value being odd, you will have the same number of petals for the rows. These are called rose graphs. The graphs are called roses. Okay. So coming to the number of petals, it's determined by, let's say we have a cos n theta. N can be odd or even. Okay. Now this is going to be the amplitude. However, if n is odd, it will have n petals. Okay. If n is even, it's going to have 2n petals. Any questions, guys? We'll continue this graphing next week. Okay, always we'll compare a linear graph and a polar graph. For now, we'll stop here, but I'll continue this roses. Then we'll go to cardioids and limesons, and then we'll go to rate of change in polar graphs. Any questions for me?
Miss Priya, just to make sure, like as the period increases, it takes more petals to complete, right?
As the period, what does it mean, ma?
Like as the period goes from like, okay, in one graph the period was 2 pi, in the other graph it's like 4 pi or something. So like the amount of petals to complete the period increases, right?
Correct. As the petals increases, the period increases. Correct.
Yeah.
Yeah, but then again, tomorrow tomorrow if I bring up 4 cos 6 theta, what will be the cycle? 4 cos 6 theta, this is even, right?
Yeah.
So that still is 2 pi, but the number of petals will be
6.
Even it is to double, right? I'll show you.
Also 12
Yeah,
petals.
so basically even means you have to double the petals, 6.
Oh, okay, so 12.
You see, yeah?
Yeah, I see.
Similarly, if it is 6, 6 term we tried, right? So it's going to be 4 na 8 petals. You see what I mean?
Yeah, I see.
So, but if it is going to be 10 na, it will be 20 petals. Okay, but if it is going to be 9, it's going to be 9 petals only.
Mm-hmm.
Make sense?
Yeah.
Yeah, and we'll continue next week. There's a lot. Okay, we'll go to cardioids, inner loop limesons, dimpled limesons. Lot is there, but we'll do next week, and rate of change is very easy. Any questions? The graphing piece alone you need to get used to. Any questions? Okay, guys, I'll stop here, guys, and see you all next week.
That's true.
Bye, guys.
Bye.
Thanks, Priya.
Bye,
Thank
guys.
you.